Hello everyone, December 9th, time crunch. Let's get this done and call it a day. Transpose. What does transpose mean? It's diagonal change, right? Yeah, diagonal change is transpose. So we go diagonally. Is it a square matrix? Oh, it's not necessarily a square matrix. It doesn't say m equal to n. How do you transpose a non-square matrix? Oh, it's okay. It's a little bit more complicated than that. Because yeah, transpose. So it can be a non-square matrix, which means you have to. All right. So I was going for in place, but now in place is not gonna work. It has to be create a new one. That's fine. We'll create a new one, and we'll go Java int. So basically, all the rows become columns. That's it. And I was trying to say maybe we can in place, but yeah, it's not in place. That's fine. That is fine. So basically, m is matrix dot length, n is matrix 0 dot length. Okay. So int data equal to res new int, so be n, right, and m. Okay, then what we need to do is first row for int I equal to 0, I smaller than m, I plus plus, for int j equal to 0, j smaller than n, j plus plus. Okay, then we do matrix, no matrix, res j, right? Because now we're filling the first column, ji, right? So we just switch them, right? So 0, 1 become 1, 0, 0, 2 become 2, 0, right? 2, 1 become 2, 0 becomes 0, 2. Yeah, I think that's right. This shall equal to matrix ij. And then we'll return res. Okay, let's see. Let's do one more. Hey, I think you're putting extra. All right, let's see. Yeah, I think this shall be it. Yeah, nothing special. Eight, 7, 6. 8, 6, 7. Okay, that's good. That's good. Let's go 10. Okay, we're doing this. Let's take a look at another one. That's barely 5 minutes. You're given a binary. Oh, this one I might need to write something down. So let me connect my write board. Okay, we'll end this at 10:30. So we have 10 minutes. Let's see what we can do in 10 minutes. All right, we have a binary array nums. A subarray of array is good if it contains exactly one element with a value. So we only have 1 bit, right? Return an integer denoting the number of ways to split the array nums into good subarrays. As the number be too large, we have to modulo it. A subarray is non-empty sequence within an array, and we know what a subarray is. So in this case, so we are trying to find the number of ways to split the original into good subarrays. So in this case, I can split this way, and this way. So I have 3 ways of splitting this. This probably have 2 ways to splitting this. No, there's only 1 way, because after split, the other side is nothing. All right. Let's see. So if you're given 0, 1, 0, 0, 1, right? So each subarray has to contain at least 1, 1. So we go through everyone, find the first one that is a split. Basically we identify all the ones, right? We identify all the ones is here, 1 is here, and then all the way to the left they have to be all combined. All the way to the right they have to be all combined. Okay, so that's the left and right, but what about the things in the middle? Well, let's say this is the first one, okay? And we have another one. We have a bunch of 0. I don't know how many zeros in between, okay? So let's say we have, P0 here and Q0 here, and then this is the last one. Because this doesn't matter. Any 0 to the left of the first and any 0 to the right of the last doesn't really matter. So now we just need to try to see how many different ways. Well, we can put it here. So basically we do no matter however many ways, because there is only one, you just push this in between every single one, right? Because you can put it here. So you can find out how many ways you can put the divider in between these 2 ones, depending on how many zeros you have, right? Depending on how many zeros you have. And if you have p zeros, right? P zeros, then you have p minus 1 gaps in between. So each gap you can put a divider. So p minus 1 plus this will be p plus 1 number of dividers you can put in between these 2. And for each one you put, you can have, q plus 1 number of this. So all in all, there should be p plus 1 times q plus 1 number of ways in total. Because no matter what divider you put here, you have all these. So in this case, we have 2 zeros in between. So that's 2 plus 1 is 3, and that's it. And this one, we have basically no 0 in between. There's nothing in between, so there's only 1 way, right? There's only 1 way. So the way to do it is, it's a Python, right? It's a Python. I'm trying to see if there is any. So we iterate from left to right, okay? And then we hit the first 0, which is we hit the first 1, okay? And then we keep we just hit the first 1, we get a pre, okay? That's it, index. And then we start from this pre, go for the next one, right? We go for the next one. And whenever we find the next one, we will find how many is in between. So it says 0, 1, 2, 3, 4. 4 minus 1 is 3. Oh yeah, there's 3 in between. 3 gaps, 3 dividers you can do. Right, so you find it, you do the minus, you put it into result. Good, and then you go all the way to the end. And we have the last one, then we're done. Okay, so we can, let's Python this. All right, let's go 5jv and copy. We say res equal to 1, and we need to find the first one. We can say pre equals nums dot index 1. This gives you the first one. What if it does not exist? That is a good question. Actually, I'm not 100% sure what is going to be happening if I have an array without 1 and I say a.index1. What's going to happen? It throw an error. So in that case, maybe we can do I think we have a better idea. We do -1. Okay, we do -1, and so this one we say for I any enumerate nums, which is fine. And I say if n equal to 1, right? If n equal to 1, if n equal to 1, so the pre has to be larger or equal to 0, right? And then we do another check. You want to do another check? Do you want to do another check? Yes. I kind of don't want to do another check, honestly. So in that case, I might as well just, pre-0 while pre smaller than len nums, right? And nums pre is equal to 0, right? We'll do pre plus equal 1. Blah blah blah. But how do you know? Well, if it gets larger, right? And then we say if pre is larger than 0, no, larger equal to len nums, right? Then we'll return 0. So in this case where there is no ones in nums. Otherwise, I can say for I in range from pre plus 1, right, all the way down to len nums. Then we can say if nums I is equal to 0, no, not equal to 0, if nums I is equal to 1, res equal to res times I minus pre, okay, I minus pre, and we'll mod. So we probably need to do a mod, right? 1, 2, 3, 4. I think I can do 1e9. 1e9 plus 7. Okay, so let's go down here. If this, no, I need to delete these 3 lines. So res equal to this. What else? After we do that, pre equal to I. Right, and then we keep going until the last one. Right, now we're done. We'll return res. Okay, give this a shot. Let's also that was a terrible take. We need to put more in between. Okay, this is a pretty, gnarly one. Can do another one like 0, 0, 0, right? 1, 1, 1. What about 0 by itself, 1 by itself? We'll take a look. Oh, that was not right. What happened? 3.0. What? How does that happen? Oh, this. Huh. I did not realize 29. Ah, screw this. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's interesting. Oh. I was going to say it's slow, but it's actually not that bad. It's not that bad. Alright, let's just do this. Da 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 da. Count the number of zeros in between any two ones. The number of dividers that one can put in between the two ones is the number of zeros plus 1. Then we just need to multiply all these number of dividers between any consecutive pairs of ones. That's it. O-N. I wonder if there is a better implementation. I'm pretty sure there is. For instance, maybe we can do, a left shift or a right shift. But essentially it's the same, right? Essentially it's the same. But then we can count, right? So while I mean that's the same thing. It's the same thing. You just same idea. This we use a pre or you can count. It's exactly the same thing. Yeah, this one is count. It's the same thing. All right. That will be it. Good. 17 minutes. Not too shabby, huh? Not too shabby. All right. Finally, we have a tough one. We'll leave this for some other time. All right. I will see you guys tomorrow. Adios.